Welcome to Pipeline Conversations, a machine learning podcast by ZenML. After a short holiday break, we're back with a new episode which I'm extremely excited to get to share with you all. Our guest this week is Ines Montani, co-founder and CEO of Explosion, a company based out of Berlin that produces tools that you probably know and love, like Spacy, a Python natural language processing library, and Prodigy, a data annotation tool. I've always found Ines to be personally inspiring in the work that she and her team produce, as well as how they present themselves to the world. So it was a real pleasure to get to dive into the weeds as to exactly how that happens. We also discuss how NLP works in production, what reproducibility means for machine learning projects, and many more things. So without further ado, please enjoy the show. So I guess to start off, I'll ask you kind of a very big question. I think you probably have things to say about it. So people who use Spacy and Prodigy seem to really love them as tools. Like, I'm a user of both, and I can attest to that for sure. Like, whether it's the tools, the interfaces, the UI, or even the documentation. Like, for me, like, I feel they like spark joy, to use that phrase. So I'm kind of wondering how you go about thinking about how to create that experience for your users, because it certainly doesn't seem like it's by accident. Like, what's the secret to building tools that spark joy for users?
I mean, that is indeed a very big question. I mean, it's definitely true that, it's not, we really think about the whole aspect of a tool and using a tool and the user experience when we build it, and I think what also helps is that we also all engineers and developers. So we kind of build tools that we want to enjoy using, and everyone's used tools that maybe don't spark joy, so of course that makes you think what could be better and how can we improve the experience and make sure that people are productive, because that's also the goal we have for all of our tools. We want people to be able to get started really easily, but also build really powerful things. So it's kind of, we don't just want everything to be like super easy and have like a very low ceiling. We want, the first steps to be easy, but then also have a very high ceiling for doing, very complex stuff, building really powerful things. And that's kind of the vision we have for tools. And I think, it goes all the way from designing an API, making things fast and efficient, documenting them, developing things further without, breaking everyone's code, stuff like that. There's just lots of small components. And it's really, I think it's quite satisfying to focus on all the small details and get them right. And I'm obviously very happy that people like our tools and feel like they spark joy and make them more productive.
Yeah, it definitely shows in the tooling. I think I can also attest to that. But as a question that we also face as a company, like making open source tooling, how do you prioritize features that come in from your user base and also maintain that level of joy? Because obviously you're probably like with the community who's so happy with the tooling, you're obviously going to have a feedback loop, which is also sort of hard to manage. How do you go about systematically making it so that the community is happy with the features you're developing and also are addressing the issues and concerns that come up?
Yeah, so I think one thing that's definitely makes this a bit trickier is that, you don't just want to be building, you don't just want to be asking your users, what exactly do you want? And then the user's like, I want to click here and then do that. And, that's fine. Maybe that's what the user wants, but you kind of also have to read between the lines. You have to think about, okay, what is really the problem? What's missing here? What does the person want to do? How can I implement this in a way that actually very general purpose and serves a wide range of users, rather than just doing this kind of feedback round and then saying, cool, you want to be able to click here, I'll put a button here, because I think that's very unsatisfying. That's not a great way to build software. And often even, when a user gives feedback, they don't necessarily know exactly, what they need. They know what they want. And you, as a developer, it's your job to interpret what this means and how you can best serve them. And I think one thing that we do is we want to be very close to use cases and practical applications. And I think having the online community helps a lot. We actually get to see what people are building and what their end goal is, rather than just getting, these really minimal support tickets. So, and I think that's very important going forward. We want to have a very close connection to the types of practical problems people are solving. And then we basically want to take this to the next level and always try to reimagine the task, come up with like different ways. How can we make the annotation more efficient for this particular problem? How can we provide different NLP components that actually really solve people's problems and so on? So it's like, there's no easy answer. I think ultimately it's like you do have to listen to people. You have to reason about what people are doing. You have to be really close to the practical world and make decisions that ideally are right. That's the secret of being in business and running a company. There's very little magic. It's like you have to make decisions every day, and you have to make the right decisions, and you have to avoid making wrong decisions.
Presumably, with such a large user base, like you often will have overlapping or conflicting like requests as well. So there, like it helps, I guess, like your practitioners as well. So you need to like be able to make those
Yeah.
calls.
And I think another aspect is we always, in all the tools we develop, we always want to make sure that they're programmable. So or kind of our philosophy there is what I like to call let them write code. So we want to build APIs that people can extend, because I think that's a great way to make sure that even more niche use cases are supported. If your product is completely closed down and can't be extended with code and the audience is developers, that can easily get very unsatisfying. Someone might have a very specific use case and it's not a feature we might want to implement because it doesn't generalize very well. It might actually not even be a good idea for 95% of all use cases. But if we provide an API that someone can program, you can write it in Prodigy, you can write these custom workflows, you can even write custom JavaScript, custom CSS. So if you want something a bit non-standard, you can just build it. You're not like stuck waiting for a feature to be implemented. And I think that's also really good for developer tools.
Yeah, I was listening to your talk. I believe it was in PyCon India, where you were like talking about that philosophy in more detail and giving practical examples. I would highly suggest anyone listening to watch that as well. I think you go a lot more in depth into that. I do have a follow-up on that particular philosophy though, because obviously that's something that we do at ZenML as well. We talk a lot about, APIs and like where's the right level of abstraction. Now, I'm wondering, how do you validate what abstraction is correct? Is there like a systematic way that you go about understanding that a particular Lambda function in through an API or a callback like a decorator is the right way to go? Or is there a validation loop at all that you've established? Or is that something that you have an opinionated decision on, that you stand by, that you have a philosophy on, and it just goes?
Yeah, ultimately, it's really about reasoning about things. Like even, as a company, we don't believe in this idea that some startups have where, everything is like kind of open and you need to A/B test every possible combination and then you end up at what's right. Like, I'm sure you can do that, but I think it's much more valuable to, reason about what you're actually doing. And I think if you have some experience programming, using APIs, building things, we also have some insights into what worked well, what maybe didn't work so well, what are good abstractions. And then, yeah, I think it's really just comes down to thinking about what makes the most sense in that scenario. I'll be very reluctant to have one set of guidelines that I work by and then, fit everything into that, because I think it really depends.
And in that vein, have you ever made like a design choice you sort of regretted it after? I mean, I'm sure there must have been those situations, but is there like also design decisions where you took the short-term hit because you knew that it was something that you had to do and that you would fix maybe a year later, but you took that hit because you had to move forward with the product? Or like, what about those sorts of decisions?
Yeah, I mean, there's a lot of small stuff that's probably not super interesting, but it's like, okay, they're like smaller things, in Spacy where like, okay, we, some naming decisions were like unfortunate, like naming is probably the number one thing we have team discussions on, even where, the one time where we schedule calls to discuss, because naming is so hard. So there's definitely bad naming. There's bad API, smaller API designs where I'm like, I wish I'd made up a separate method, or like, you don't want a method that has different return types based on different arguments. You said that's a bad design. I regret some of these. There's some other API things. On the other hand, there are also other things that have been extremely stable. Like one fun fact about Spacy is that a lot of the data structures, like the doc token span, that are really core to the API and also are implemented as if very efficient data structures in Python. Those were some of the first things that Matt, my co-founder, worked on when he initially wrote Spacy, and they actually haven't changed very much at all, because he was like, our data structures are really important. So he did that. Yeah, I guess to go back to the original question, there's some things where, for example, in Prodigy, one thing people really wanted was support to have multiple users connect to one single session or instance in Prodigy, like multi-user sessions, multi-user support. And that's obviously something that's quite relevant also for the self-hosted version, but it's also something that's very complex, and that's often a lot more complex than it sounds at first glance, because you have your data, you want to divide it up equally between people, you want to consider cases where someone just opens their browser and then doesn't do any work, while also making sure that you don't end up with like duplicate data, it's one of the things that's quite complex, and we shipped that quite early because we're developing it in the background, and we did have it was quite difficult to really make sure that it works as people expected, communicate that to the people. They're always like very subtle bugs that can sneak in. So that's one of the things where I'm like, it's something people wanted. We made a public API out of it. We should have probably, waited a bit longer. But yeah, I don't know. Those are like the things learning. It is often difficult if you have these things that are more complex they seem, for example, because you have a lot of users who are like, here's exactly what I want to do. It sounds really straightforward, and then it's and then there's another use case where someone has a similar case and they're kind of conflicting, and then you have to find a general purpose way to implement it, and then it's actually quite tricky. But that's all.
Yeah.
I guess it's all life of a software developer.
Yeah, it almost feels like at ZenML, it almost feels like when we are like thinking about design, it almost feels like we're discovering the design and it's sort of there, but then you iterate it and then you stumble upon something over the weeks, over the months as you get feedback, and you were like, why didn't we think about that earlier, or like why did we make that certain decision, and so on and so forth. It is
I
interesting.
guess it's also difficult if your goal is to do something very general purpose, or in your case like ML ops, and it kind of needs to work for everything. That also becomes a lot harder because you can't anticipate everything that a user might want to do, but you also don't want to lock people in too much. So yeah, I can definitely relate to that.
I was wondering if you could say something maybe a little bit more on those lines around that design process, something a little bit about practically how that looks when you're I guess in the earlier stages of working on something, because it does seem that design, or kind of a design focus, is part of Explosion's secret sauce somehow, that
Do
you
you mean
do
design
spend a lot of time up.
as in user experience and user interfaces, or just the
Well,
API
across
design?
the board, yeah. It does seem that seems like you spend more time up front. From the outside, it seems like you spend more time up front thinking about these things, so from earlier on.
Yeah. I mean, back in the day when we started out, it was a lot of like just Matt and me, working on things together and building them. Like, I feel like, okay, as a developer, I have the advantage that, okay, I can also sketch out a vision. And I feel like, someone else who's like leading a team might be sketching out their vision in words or on a whiteboard. And in my case, it's like, cool, I can just implement that. I can write some code. So I think in the beginning, it was really just like, okay, we were able to build prototypes for all our products and all our libraries ourselves, so we could have this very close collaboration where we just try things out, and we probably have very similar mindsets of how we approach things, also in terms of, okay, you want to reason about what makes sense, have, I don't know, the attention to detail, consistency. I think a lot of that is just, okay, how you approach things, and might also be a personality thing. I think other people approach it differently. And now that we have a slightly larger team, we do a lot in planning documents, because we're completely remote. We have people in all kinds of different time zones, from Australia to the US to Europe to Japan. So we can't just have one call with everyone on it and discuss things. That doesn't work. That's not efficient. We also can't expect people to just always be on Slack. So we do write a lot of planning documents, proposals, and then discuss them, and then implement them, and make sure that also all the knowledge that we've accumulated internally gets passed on to other people, and we can keep
Yeah,
up that quality.
it does show in the entire product, from the docs to the examples to the actual API itself. It seems like such a unified, refined product. So like to the entire team there. Shifting gears a bit, maybe because like we are specifically focused here on ML in production, or ML ops, whatever you want to call it. I'm particularly interested in asking you about what it takes to put NLP models into production, obviously, because that's a field that you focus in. But I always love to start with this question, even before that, like, what does production even mean? What is the definition of production for you in machine learning in general? Or maybe you can even refine that down to NLP, because it feels like whoever you ask, it is a slightly different understanding.
No, it's true. Yeah, actually, internally we kind of have, when we ask companies about, like, the stage of their project or something, we usually ask about, well, development, or like, well, there's an idea, there's development, and then there's production with internal users, or production with external users. Because actually, especially if you look at use cases for information extraction, which is something where Spacy is very powerful and really lets you implement these quite powerful end-to-end pipe to analyze text. A lot of use cases are actually quite more internal than external. Not everything is like a product or a chatbot that like customers use. A lot of it is just large companies automating things internally, or improving workflows internally, and building stuff. So their production can just mean, okay, we've served something for our team, and it's providing value. So I guess maybe that's some definition, but is the thing running and providing value to your company in some way?
Yeah. 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 I've heard that one a lot. I think that's probably the best definition I've heard as well. That's exactly right if it's providing value. And it seems like NLP specifically is the facet of machine learning that is the most advanced in this, right? So we have chatbots, we have so many use cases that you can already see with NLP. Like currently, like if you look across the landscape with all the people that you're working with, how mature do you think the NLP production landscape is in terms of tooling, in terms of workflows, roles
I mean,
in organizations?
I think it really depends. I would say we've definitely seen a lot in the past couple of years, and companies, more and more companies are building teams internally. I think we've all understood that, okay, we need a lot of companies are developing things in-house. Have also seen that this is much better. You can now really train very accurate models that do exactly what you want. And so it makes a lot of sense to have your own developers working on it. And people are not talking about like, oh, are we going to buy all our AI from the AI store? Is Google going to do AI for all the companies? It's like, no, it's a type of software development. So I do think we've seen we've seen a lot of improvements and more maturity there over the years. But I think it kind of depends on the role NLP plays in the company. Like for some products, it's just like a little extra feature. Like maybe, I don't know, you have some platform and you want to provide auto translations into the user's language. It also really depends on where NLP comes in and the role NLP plays in the company and in a product. Like it could be just a feature in some online platform providing translations into the user's language. It could be something that maybe adds some extra sugar into analytics and helps people like interpret their data differently, or it could also really be of a product. And I think that really changes how companies and organizations approach their development. I definitely think there's a lot of discussion and uncertainty around like, okay, how can we keep our models up to date? How can we make sure that we find ways to do certain things better? How can we evaluate whether what we're building there actually works and provides value beyond just like looking at an accuracy score? How can we improve our data and get more out of that? How can we version these things and make sure our processes are reproducible, that we're not just running a notebook on that guy's machine and then we can
Classic
never
machine learning.
and then we lose the data and then we just have these binary files and then nobody knows where they came from and how they were like that is still the reality as well. And it's not like people are oblivious to that. People want to fix it. But I think also the fact that machine learning is code and data, and that also data can get stale, the world changes, language changes, I think adds another level of complexity. You can't just train a model and then then you're done with your AI and then you can move on to something else. It's like a continuous process. You need to iterate on your code, you need to iterate on your data, you need to constantly check and test things. And I think that's still a challenge in a lot of organizations.
Can you talk a little bit about, I guess you started mentioning some examples here, but some kind of cases where Spacy is being used like in the real world in production? I don't know what the spectrum of that looks like for production use cases.
So the spectrum is obviously from actually powering some capabilities in products, in all kinds of applications, from I think it's used in chatbots and as well as in information extraction. I think one of the areas where Spacy shines the most is when it comes to analyzing large volumes of text and extracting very complex information that's also very custom to a specific use case. So, for example, in a biomedical domain, you might want to first extract certain types of drugs or certain types of genes, and then you want to relate them to each other, or you want to find out who did what's the cause and effect of something. And often you do want to do these things in different steps. You want to have these reusable components that you can also test independently, that can build on top of each other. And you might want to have one component where you use a fancy state-of-the-art machine learning technique. You might want to have another component where you just look something up in a knowledge base, and then you want to tie them all together. And at the end, you get a structured representation out of it that you can then use in your product. Because that's another thing, like most production applications don't do machine learning for the sake of machine learning. And running your model and getting predictions out of a model is usually just a small part of your end-to-end application. Like that's usually not where it stops. And that's also usually why like just having one API that kind of accesses your model is usually not enough. Like you need to program around it because the predictions mean something for you specifically, and you want to do something with that. Whether it's populating a database, triggering some other processes, anything, but it's usually there's often something that from your pipeline and the predictions.
And so, like, generally speaking, are you seeing or finding that the person who's doing the things around that model, that they're also doing the other things around the edges of it as well, or is it more often they're combined in that sense?
Yeah, well, I think you kind of have to. Like in general, I would advocate for the machine learning developer also having a good sense of what the model will be used for. I think a lot of problems occur when you're trying to develop like a machine learning component in isolation without actually understanding, the larger purpose of that model, because then you're just sitting there and trying to tune it on accuracy, and maybe later you find out that what you're predicting there in the first place isn't even that useful, or the way you are breaking down the problem isn't the right way to do it, because there are lots of different ways you can break down a business problem. And often the business problem won't come to you in the shape of a machine learning problem or a prediction problem. Like the business problem might be something like, oh, we want to analyze these incoming emails, or we want to analyze all of these reports that we have internally. We want to analyze these journals. We want to analyze these news articles. We want to find something out about it. And then based on that, we want to trigger some action. And that often doesn't map neatly into something you can predict. So you have to think about what's the best way to break this down. Maybe we want to predict something over the whole text. Maybe we want to split the text up first and then predict something over it. Maybe we want to simplify certain parts of the text and then extract spans of text from that text. Maybe we have some dictionary that we want to use to link certain entities in the text to, and so on. There are lots of these decisions, and you can only really make these decisions if you know about the problem you're solving and about the machine learning side of things, and you know what's possible. You have the different components and know their like advantages and disadvantages, and then you can pick the perfect pipeline to do it.
Is that so? As far as I can surmise from that, you're advocating almost for this full stack data scientist role situation. I also like personally completely am in agreement with you on that, but a lot of pushback I've had when I've said that has been the fact that these people are unicorns. They don't understand production systems. They're from statistics background, whatever it is. You can't make them understand Kubernetes or production systems or stuff like that, right? So what would you say to the people who push back on owning the entire process end to end with that sort of sentiment?
Yeah, I mean, you don't necessarily need one person that can literally do everything. Like, I don't think I understand Kubernetes, and I think that's like fine, but it's still, they're just general. You should understand the whole end-to-end process or know what's going to happen. For example, yeah, even speaking of like productionizing or serving things, if you know that like latency is super, super important because you need to be really fast, then that really changes how you design the application. And that even goes all the way back to the machine learning model implementation. If you know that this thing just needs to be fast and you don't actually care about accuracy that much because you're going to be averaging over the predictions, but what you really need to care about is like that it needs to be super snappy, then you might choose a different way of breaking it down. You might not use like the largest, like slowest embeddings. You choose an architecture that's faster, or the other way around. If you're like, oh, I'm going to parallelize this anyways, I don't care about that part. We're just, serving this at scale and running like hundreds of jobs in parallel. Then you can say, okay, I choose something that's a bit more tuned to be more accurate, and where speed doesn't matter so much, and so on. Like, I think these are all, and that's just like at the very, very surface of it. So yeah, I think it's just important to understand that. And again, also, I think it's very important to understand what's the purpose of the system. Like, we talk a lot about like, harmful AI systems, or a situation where, all of a sudden in very unforeseen ways, the application does something that's actually pretty bad. In a lot of cases, this, could have been avoided by actually having everyone working on the product engaged with what is this thing supposed to do? What happens if, this is a machine learning model, it predicts something. What is this trained on? Where can this go wrong? How can we mitigate that? How can we do this differently? I think these are all very important questions.
Yeah. It's almost, I feel like it's an own thing. So this is where the role of higher level abstractions such as Spacy or such as like TensorFlow or any other thing that sort of abstracts away complexity, but then gives the process ownership towards certain roles so that they can own certain things and not necessarily understand the underlying technologies, is where it's important tooling and systems that mobilize in a certain way.
But I think that's
Like,
also
I
why
think
it's
come into the
important to find the right abstractions, and not because I think a lot of ways that people might think of to make machine learning easier is often just like adding leaky abstractions on top of it that don't actually solve the problem. Like, yes, you want the technology to be accessible, you want it to be like easy to use, easy to get started with, you don't want to spend time doing something that's not necessary, but at the same time you also don't want to just cover up all the complexities and all the scenarios where you do have to make decisions and design things in your own way. Like, I think that can also be quite harmful because you're not actually solving problems, you're just abstracting away the complexities, and the complexities are still there. And I think it's still, yes, nobody needs to understand like all the details of like the model and optimizer necessarily that that they've chosen and that works, but people should understand how a machine learning model and this given machine learning component works and what its predictions are based on and how you can influence that, because that's what absolutely core to what comes out at the end. And if you have a basic understanding of that, you can also make better decisions in like how you create the data and how you can solve problems that you encounter. Or you can also just save a lot of time, but you can waste so much time optimizing the wrong thing when maybe the solution would have been to just create the different data or break down your problem differently. So
to keep going down that road a little bit, specifically for Spacy and like in terms of these production use cases, presumably there are certain things that Spacy handles for kind of production scenarios versus things which they don't, in terms of common things which go wrong or which just need handling. Like how do you think about that for Spacy?
Yeah, so one thing that is quite important to us is that we want to make sure that, okay, you can use the tool for its purpose, but we also want to make sure that there's a very clear scope around what the library does and what the library doesn't do. Like, I think it can be quite counterproductive if a library or tool you use wants to own your whole end-to-end workflow and doesn't actually like slot into your development workflow. Or it's what I sometimes talk about as, it's fine to reinvent the wheel, even though some people might tell you it's not, you should never reinvent the wheel. I think it's okay to reinvent the wheel if you have a really good idea, but you shouldn't be reinventing the whole road, because I think that's where a lot of problems happen. And so we really want to make sure that, okay, Spacy is very well scoped to its purpose, which is a library for build end-to-end pipelines to solve complex and advanced natural language processing problems and train natural language understanding systems on your own data for your own very custom problems, and make sure you're really running these end-to-end experiments and also keep your work reproducible. So there are some features we introduced in Spacy 3 that go a lot more into the workflow direction. So one of them that was quite new, or a bit sort of a bold move at the time, because we thought, well, there's so many settings and so many things that do matter for an NLP model and an NLP pipeline. You have like the different components, they all have their models, they all have their hyperparameters, you have the general settings of which language to use, how to tokenize your text, how to batch things up. Like there are all these settings, and a common problem you see if you have a lot of settings is that you have to work with defaults, you end up with hidden defaults. One setting is wrong, your whole thing collapses. It's very, very difficult for someone else to rerun your exact experiment. So we basically introduced this config file that has like all settings that are relevant for your model. So you can auto-generate that, and every setting and everything that's relevant is in there. And it can also refer to code and functions. So you can really, if you want to have a different way of batching things up, you can include your own function and reference it in the config. And so you can customize the process at every step, but you can also just use the defaults. But all defaults are kept in one place, and that really helps because it means you can send your configuration to your colleague, and your colleague can run it exactly with all the same settings and reproduce your results. You can check it into Git. That's definitely something that we saw was a problem people were having and a problem we wanted to solve. And similarly, we have a Spacy project system that works a bit like a CI config file, where you can define a series of commands that runs in order from training, evaluating, testing your model, visualizing it, because we've also seen that often there's more than just training. There are different steps, there are different things that might not even be in Python code. So we wanted to make sure to provide a good way to distribute these kinds of projects that people are working on, from downloading your data, pre-processing, to training, to evaluating, and maybe then deploying, tracking. If you can run it in code, you can just integrate it and Yeah.
Was the motivation behind that kind of a sense that people wanted to stay within the Spacy ecosystem? Because obviously there are like at least some tooling kind of options in that space around whatever, having reproducible workflows
Maybe,
and
but
so
I
on.
think
I
I
think
don't
I
know. I
may have
think
cut
we
out.
also just wanted like a lightweight way of providing that, from the Spacey side of things, because they're obviously their tools. We don't want to. We were very careful to not try and be like everything. I think that's reinventing the road. That's like quite harmful. You don't want to be, try to be like a shittier version of an experiment management tool. Instead, we're like, here's an engine that's built into the library that can just let you orchestrate these things. What these things are up to you. It doesn't have to be our stack. It can be any stack that you want, but it definitely helped us, basically, achieve a situation where people can have these script these end-to-end workflows around Spacy more efficiently, and to have like reproducible training in a unified format that's scriptable with code that's extensible. You don't want to program in a config file. You don't want to have a program just, you can program just in code, but there's just like a ton of settings that you want to record in a different place in a file. And yeah, and of course also we are opinionated in the sense that, okay, we want to build something that's exactly right for the use case. So we want to build things that are lightweight, and we want to build things that are scriptable so that they can integrate with other things in the ecosystem.
And in general terms, what does reproducibility mean for NLP? Like, are there different stages of the workflow where this will come up more than others? Are there different kinds of reproducibility maybe for different use cases, or is there a general definition?
I mean, I think I don't know. At least based on my definition, I think it starts at a very, very basic use case of like, okay, you're two people, one person trains a model, and the other person should train the same model. Are they able to do this without too much hassle? Like, I think that's for the practical use case. It's like, okay, you've run some experiments, you've tested out a bunch of things, you maybe found something that works and gives you good results, and now you want to send that to your colleague so that they can train it, or you want to put it, train it on a server, you want to integrate it into your like deployment pipeline. Does this work? Or do you immediately run into problems where, you don't really remember how you configured this, or a version changed and suddenly some setting is different and you don't get results anymore? And also, especially with like, with modern NLP specifically, like, I don't know, I think it's similar across the board for machine learning, but like there are a lot of use cases where you're training a model and that one specific tiny setting really, really matters. And, it literally is about whether your learning rate is 0.001 or whether it's 0.0005. And that's what decides everything. And that's not so much fun, but like that is a fact of life. And so you want to make sure that this is something you preserve, because even really tiny differences can, make a huge difference and slow you down. And then you spend like days debugging. And I think another aspect of this is I think it's important to close the gap between prototyping and productionizing. And I think a problem that a lot of teams still have is that you have this whole workflow for prototyping where maybe people are hacking around in notebooks, or you're just like building something, you don't care about like how it runs or performs or how nice the code looks. And then you have this whole other process of now someone needs to sit down and productionize it. And that can often go wrong. It takes way too much time. Someone probably has to redo the work. Maybe actually while productionizing it, you find out that, well, it doesn't actually work because it's too slow, and there is no way to just magically make it faster. That's not how it works. The whole approach is wrong. And then you've wasted like weeks or months on this. And I think a good way to solve this is by closing the gap and making the process of prototyping much more aligned with what you're deploying later. And I think that includes already using good tooling around the infrastructure, around the operations, around reproducibility, around experiment tracking during development and while you're building a prototype. And also, it's important that even developers who are prototyping use some of the best practices or work with frameworks that already optimize for efficiency and that are extensible. The result should be good code that you can work with. You don't want to deploy something that's just kind of held together by duct tape, and where nobody, I think we all know these code bases where like, yes, they're deployed and they're running, but nobody really dares to touch them because you're like, oh, if I change there's kind of a bug here, but if I change one thing, maybe everything will fall apart. So I'll just never go in there. And that's obviously bad. You don't want your machine learning model to be like that.
Yeah, we have a thing internally at ZenML where we take a day to take a famous repository in machine learning and try to productionalize it with a pipeline. And I can definitely attest to the fact that there are so many famous, much used repositories which shall not be named out there, which are not reproducible at all. So it's just the fact, like the state of things. And I think the tools such as Spacy have really pushed the boundaries forward in building best practices and like bridging that gap. So completely agreed. I want to perhaps switch tacks towards the company a bit, because
Yep.
you recently, your like financing round, you have been like not like probably staving away investment for years now, but you finally did it. And that also involved like growing the team. And
Yep.
I know that you were a small team for a number of years, and now you're also relatively small, like given the
Yep.
scale of the actual like user base. I was wondering, how do you actually go about organizing your team in terms of building fantastic tooling? Because, for example, when I was on your website, I didn't see any person who was specifically focused on one part, like someone who's focused on content production, or someone who's focused on design only, or something like that. And as we spoke about earlier, design and just a unified ecosystem, whether it be docs or examples or the API, like there seems to be one golden line flowing through all of that.
Yeah.
Is that something you've baked into the company as you've hired? Is that in the roles that every engineer also produces that sort of content and design, or do you have specific roles that you've assigned people?
I mean, I think that's an interesting question. I think it's definitely, it kind of depends. Like, we do have some people who are a bit more specialized. Like, we do have people working on front end, especially more on like Prodigy teams, which is our upcoming product. And we do have people who work a bit more on like actual visual design there. But for the engineering team, it's definitely important that like someone always, like people who we work with always have the full picture in mind. It doesn't mean that everyone needs to do exactly the same things, but of course there's some people who are more interested in technical writing, other people who are a bit more interested in you know like more back end hardware type things. It really depends. And I think also as a small company we can, or as with a small team especially, we can really take advantage of people's individual skill sets. Or I've referred to this previously as tree-shaped skills as opposed to what people normally call T-shaped skills, like kind of like the letter T or T-shirt, where you have a strong foundation and then some other things that you're doing. And for us, it's more like, oh, it's a tree. People, you can, the tree metaphor is a lot more live. You can, it takes into account that you can develop new skills, you can grow new branches, people's skills can overlap, and you can just like, you have a foundation, but you do a lot of different things. And that can be quite different for different people. We're not hiring people with this sort of old school large tech company idea in mind, where like you want every engineer to be exactly replaceable and interchangeable. Like it makes sense. Look, I understand Google has to hire that way, otherwise it's not functional. But if you operate a bit differently as a company, you can hire a bit differently. And I think we've really benefited from that. And I think it is kind of core of the company, because I consider myself sort of a person with a very mixed skill set as well. Like I've done web development, I do machine learning stuff, I do software development, I write things, I do all kinds of stuff. And I might, I don't fit very neatly into a typical software engineering role. And probably even, similar for my co-founder. So that's ran things. And we do need the team to be quite independent as well. Like, we want to work in a way where everyone has like some agency and some ownership over the work they're doing, and can also just, go away and program. We're not, also, I think another big problem, even with growing companies and growing teams, is that a lot of startups really like to, design their org chart before actually hiring people. It's sort of like this playing house thing. You get like, you have some money, you get like a nice office, and then you're like, oh, let's like plan out an org chart and then fill all these seats. I think this might work for some people, but I think in a lot of scenarios, this can be quite counterproductive, because, you want to just see how your team comes together organically. You don't want to just plan in 5 layers of management before you've like even hired people. So yeah, I think for us, like, growing organically also had that like advantage that, we were able to just see how things come together. We're remote first as well, which means, we need to communicate asynchronously. We need to make sure that, okay, there's a lot of state is preserved in written communication, and we can't just rely on like all sitting next to each other in an office all day.
Yeah. Yeah. Awesome. And I think that gives a lot of hope and inspiration to other like tree-based profiles out there. I would like count myself. I would count myself also in that category. So I love that analogy. Thank you so much.
So we always end with kind of two final questions for people that we speak to, kind of quick questions, which you can take in whatever direction, I guess, that you like. So firstly, what would you say, or what would your idea be of a quick win that someone can add to make their productionizing of models more robust?
I think, I don't know if it's a quick win, but like, I think if you try to avoid having two different workflows, prototyping and production, like try to decide, on one workflow, try to avoid having, roles in your team of someone who just implements scrappy versions in notebooks and then someone else who implements them properly. Like this is not great for like your general culture. This is going to probably waste a lot of time, and you want to have ideally you want to have one workflow. You want everyone to write code in the same way, regardless of whether they're just trying things out, building a prototype, or whether you're actually building your final product and shipping it. And I think coming up with some best practices there is good. You want to learn from mistakes, do like little postmortems on like what hasn't worked, and then ideally find one workflow that works and stick to that.
Nice, very, very practically minded. And I guess kind of what would be one other part of putting a model in production that you think maybe hasn't been given enough attention by tool makers and maybe should be given more attention?
Oh, I think that's definitely iteration. Like people, there's still, there's still this idea that like, oh, you put in all the work, you develop your model, you collect your data, and then you train, and then you're done. And the reality is you're kind of not. Your data is going to get stale. The world is changing, language is changing, especially in NLP. You want to keep developing your model. Like you're never done. Like you're never done writing code, you're never collecting data, and you're never done training a model. You want to continuously annotate, you want to continuously train and test your models, and you need to iterate on your data. You can't, you don't want to be outsourcing your data collection. You really want to focus on how should my application work? What makes sense? How should I be breaking down the problem? What's the best way to approach this problem from the machine learning perspective? And then you need to keep working and working and working on it. And I think that's incredibly important. That is something, that we've seen, didn't get enough attention. And that's something we also want to be focusing on in our stack to kind of help people keep their pipelines and workflows up to date, and, keep training, keep improving, keep iterating. Yeah.
Awesome. Ines, thank you so much for joining us today. It was really fantastic to see all the insights that you picked up over years of developing awesome tooling. Would you just leave us with a final note to the audience of how, if they were inspired by you today, if they wanted to get in touch with you, how they would do so? What would be the best avenue?
Yeah, thanks for having me. This was great. I think, probably the easiest way to connect is you can follow me on Twitter. You can follow me on LinkedIn. You can check out my website where I usually collect podcasts, talks, and other things I'm doing. Also, I apologize in advance. I often tell similar anecdotes in the podcast. So if you listen to another podcast by me, you might hear like something I've actually said today. Like anyway, so I think those are the best avenues. You can check out Spacy, which is our open source library for NLP. You can find us, on the internet, and you can read the documentation. You can find us on GitHub. You can check out Prodigy, which is our annotation tool for creating training data for machine learning models. We have some cool videos on YouTube if you like watching videos and seeing kind of end-to-end use cases. And
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.